Can a passive optical fiber have negative loss? No. If your tester reports a result like that, physics is not the problem. The reference was probably set incorrectly. In this video, we will show the correct one-jumper reference method on the AEM TestPro and the single move that can invalidate every measurement that follows. The reference establishes 0 for insertion loss and length measurements. With the one-jumper method, each direction uses one test reference cord. One connects the main transmitter to the remote receiver. The other runs from the remote transmitter to the main receiver. No couplers or extra connector pairs belong in the reference path. This method leaves both end connector pairs of the link in the final result. That is why it is preferred for typical patch panel to patch panel certification. One important distinction: 1, 2, and 3 jumper describe reference methods. Tier 1 and Tier 2 describe certification scope. They are completely different numbering systems. 2 jumper subtracts 1 connector pair loss, 3 jumper, 2. Use them only when the link requires it. Before connecting anything, inspect every end face. The rule is simple: inspect, clean, inspect again. A dust cap does not prove a connector is clean. It provides mechanical protection, but it can also transfer contamination. The same applies to a brand new cord straight out of the bag. If contamination enters the connection used for the reference, the tester may treat that loss as 0. Worse, the dirt can migrate to the mating connector. So do not clean blindly. Inspect first, clean only when needed, and verify the result. After powering up both units, allow the optical adapters to stabilize for at least 5 minutes. During that time, the optical system reaches operating temperature and the source level stops drifting. Lay the cords loosely. Do not pinch them, create tight bends, or change their position during reference and testing. Mechanical stress can change the result, especially with multi-mode fiber. On the AEM TestPro, open Fiber Certification, then Tools, Set Reference, and select One Jumper. When the operation completes, the instrument displays received power at both ends. Main and remote do not have to show identical numbers. Each unit is measuring the source located at the opposite end. For multi-mode, TestPro requires at least -24 dBm. For single mode, at least -4 dBm. If a threshold is not met, do not press. Accept and hope for the best. Return to inspection, connections, and reference cords. The reference is set, but we are not ready to certify links. First, we must validate the additional cords that will connect the testers to the fiber under test. Here is the most important rule in the entire procedure. Never disconnect the cords from the transmitter ports marked TX. At each receiver, add a second cord that has already been inspected. Use a coupler to connect its free end to the cord coming from the transmitter. Do the same in the opposite direction, then run an auto test. For multi-mode, the added cord should measure less than 0.10 dB. For single mode, less than 0.20 dB. Do not confuse those values with the received power thresholds used during reference. -24 and -4 dBm answer whether TestPro is receiving enough optical power. 0.10 and 0.20 dB answer whether the added reference cord is good enough. Save the cord validation result. Do not store it as the next fiber identifier. Save a separate record with the date and cord identifiers. If marginal results appear 2 hours later, you can return to that evidence and confirm the condition of your setup at the start. Now open the path at the couplers and insert the fiber under test. Do not touch the transmitter ports. Inspect every end face again before making each connection. After the auto test, do not stop at the large pass label. Verify the identifier, length, polarity, loss at every wavelength, selected limit, and margin. Only that complete set of information tells you what was actually measured. Set a new reference whenever a TX cord is disconnected, a unit is power cycled, an adapter is removed and reinstalled, or a reference cord is replaced. A Tier 1 measurement reports total end-to-end insertion loss. It answers one question: does the entire link fit within the loss budget? It does not tell you where the loss occurs. A link may pass the aggregate loss test even when one splice or connector misses the workmanship criterion. Use an optical time domain reflectometer for Tier 2 event location and evaluation. Tier 2 complements Tier 1. It does not replace it. Remember 9 points. The correct project. End face inspection. At least 5 minutes of stabilization. Direct transmitter to receiver connections. Received power checks. Never disturb TX. Validate the additional cords. Save the evidence. Only then measure the link. The complete certification course and interactive simulator are available in the free Interlab Academy. And if you need one platform for copper certification, insertion loss testing, and OTDR, take a look at the AEM TestPro.